At 4:14 local time on June 24, 2025, a Russian Cerna-class landing craft cut across the Black Sea toward the western shore near Kherson, carrying roughly 30 troops who believed they were moving through empty water. They were not. For the past 27 minutes, a Turkish-built Bayraktar TB2 had been watching from high above, patient and invisible, turning a quiet transit into a countdown. In the next minute and a half, a routine approach would become a hinge point, not because of luck, but because someone had already done the slow work of finding the target before the target realized it was in a story at all. The drone had launched at 2 o'clock local time from a concealed site near Mykolaiv, while the sea below was still pre-dawn darkness and the horizon offered no friendly light. This was the hour where fatigue becomes an operational variable, where radar screens blur and operators fight their own eyelids as much as any adversary. The TB2 did not need speed, it needed time. With endurance described as roughly 27 hours, it could afford to be methodical, accepting long minutes of empty footage as the cost of being present for the one moment that mattered, and building the kind of silent advantage that never shows up on the surface of the water. Its movement to the patrol area was not a straight line, because straight lines are for peacetime navigation. The route was shaped around the risk of Russian air defense coverage, keeping at least 50 kilometers from known Russian S-300 sites, rather than testing fate with a closer pass. The logic was simple. A small radar cross-section might help, but arrogance gets aircraft destroyed. The drone's job was to exploit gas, not challenge the strongest points, and to arrive without announcing itself. This is what modern surveillance looks like when it is done correctly. The hardest work is invisible, and the reward is that the enemy never gets a clean moment to react. The TB2's pace matched that philosophy. Powered by a Rotax 912 engine and cruising around 70 knots, it moved like a hunter that already knows the night will last long enough. The value was not drama, it was persistence. A platform that can stay up while other systems cycle out creates a different kind of pressure, because it can wait for patterns to reveal themselves and can watch the same routes long enough to notice what does not belong. Over dark water, that matters even more, because the sea hides sound, hides wake, and hides intent, until a sensor decides to make the hidden visible. By 3:30, the drone established a patrol box roughly 40 kilometers long and 20 kilometers wide, positioned to cover the maritime approaches to Kherson. It was a rectangle of airspace with a purpose. Watch the lanes that lead to shore, and do it for as long as necessary. The TB2's Canadian-made Westcam MX-15D sensor suite provided the eyes, combining electro-optical and infrared modes to turn darkness into readable information. From altitude, cold water becomes a uniform background, and any engine heat, human presence, or warm wake becomes a signal that something is moving with intention. Inside the ground control station, the work is both mundane and relentless. The operator monitors the feed, cycles between visual and thermal views, and resists the most common failure in surveillance, assuming that nothing will happen because nothing has happened yet. Drone warfare is defined by long stretches of quiet that punish attention and by brief windows where attention becomes decisive. The TB2 flew its pattern, while the operator watched for deviations, anomalies, and motion. Because on the sea, even a small change in heat and direction can be the first sentence of a much larger plan. At 3:47, the thermal display produced that change. A distinct hot trace moved west at about 30 knots, leaving a warmer wake against colder water, a simple signature that immediately suggested machinery rather than waves. As the operator refined the view, the contact resolved into a Project 11770 Cerna-class landing craft. This was not a random boat, it was an amphibious workhorse, built for shallow draft approaches and fast delivery to beaches. The craft's profile mattered because it narrowed the list of likely missions and because it implied a deliberate approach toward land, not a casual transit between ports. Then the picture expanded. The Cerna was not alone. 2 more vessels followed roughly 5 kilometers behind, confirming this was a convoy rather than a solitary run. Convoys suggest coordination, contingency, and a plan worth proceeding. The operator tagged the contacts and began recording, because the value of surveillance is not only stopping an action, but proving what the action was meant to be. With the lead craft moving confidently, the drone held position at altitude, letting the sensor suite do the work. The sea offered no warning to the troops below, and the convoy continued as if it owned the darkness. The lead craft's movement and design reinforced the threat. With shallow draft and water jet propulsion, it could maintain speed and still approach a beach, the kind of platform used when you intend to put people or equipment ashore quickly. On the deck, thermal spots suggested multiple human heat signatures, clustering in ways that did not resemble sailors simply maintaining a vessel. The operator interpreted the patterns as infantry presence rather than routine crew activity. And the observation mattered because it framed the convoy as an operational package, not a logistical errand. The drone was no longer watching boats, it was watching intent. By 4:10, the approach vector clarified where that intent pointed. The convoy was heading toward a specific stretch of beach about 8 kilometers west of Kherson, a location Ukrainian forces had previously flagged due to suspicious activity. That contextual link turned surveillance into urgency. A route that matches prior concern suggests preparation, and preparation suggests a planned event rather than coincidence. The operator pushed information up the chain through secure channels, because at this stage the value of the feed was not only in what it showed, but in how quickly decision-makers could act on it without losing the window. At 4:15, authorization to engage arrived from the 383rd UAV Brigade Operations Center, where senior officers were watching the same live feed and weighing the trade-offs in real time. The decision carried risk. Firing would expose that Ukrainian drone coverage extended this far south, potentially compromising future surveillance, and the munitions were limited and costly. Yet the convoy's direction, composition, and timing outweighed caution. The operator shifted from observation to action, preparing to strike the lead vessel first, because removing the front element creates confusion, disrupts coordination, and forces every following plan to improvise under pressure. The setup for that strike depended on precision rather than spectacle. The plan was to align from behind to optimize the MAML's semi-active laser homing along the target's axis, then maintain steady designation through the weapon's roughly 43-second flight from an optimal release range of about 8 kilometers. The drone remained at 18,000 feet as the operator watched the Cerna close toward shore, noting troops in tactical gear and assault rifles among the crowded deck positions. The sea still looked calm, but the situation no longer was, because the moment the missile left the hardpoint, the convoy would finally discover it had never been alone. As the Cerna closed to within roughly 15 kilometers of shore, the operator narrowed his focus to details that only mattered now. Movement patterns on deck suggested anticipation rather than routine, with personnel shifting positions and checking equipment in ways that hinted at readiness. The weather cooperated, with light winds at altitude and clear conditions that simplified laser designation. Nothing about the scene suggested urgency to the Russians below, but to the operator, predictability was the most dangerous feature of all. Targets that hold course, speed, and heading make the mathematics of interception brutally simple. At approximately 4:30, a subtle shift occurred on the lead craft. Through the thermal feed, crew members moved toward the bow and began setting up what appeared to be a heavy machine gun mount. Whether this was standard procedure for approaching a potentially hostile shoreline or a reaction to something unseen was unclear, but the implication was the same. The margin for patience was shrinking. The operator ran through his checklist again, verifying laser stability, munition status, and flight parameters, because once the attack began, there would be no room for hesitation or correction beyond instinct. The MAML selected for the strike was not large by conventional standards, weighing roughly 22 kilograms with a 10-kilogram warhead, but its design favored precision over mass. Built to defeat light armor, it was more than sufficient against the thin steel of a landing craft hull. Its effectiveness depended entirely on uninterrupted laser designation, which meant the operator would need to hold the beam steady for the full duration of the missile's flight. At an 8-kilometer release, that meant committing to a decision that would unfold over tens of seconds, not milliseconds. As the Cerna continued its approach, the range ticked down from over 12 kilometers. The operator waited, resisting the temptation to fire early, even though the missile could theoretically reach farther. Accuracy degrade outside the optimal envelope, and this was not a shot to gamble. Every second of waiting increased risk, but every second also improved the probability of a clean hit. Below, the landing craft maintained speed and heading, unaware of the calculus unfolding above it. To the troops on deck, the night still felt ordinary enough for cigarettes and casual movement. By 4:42, the range reached 8 kilometers, placing the target squarely inside the ideal engagement zone. Yet something felt incomplete. The two trailing vessels, still 5 kilometers behind, began to alter their behavior. One drifted north, the other south, forming a loose perimeter rather than following directly in line. That maneuver reframed the entire picture. This was not simply a landing craft with escorts. It was a coordinated insertion, with security elements positioning themselves to control the surrounding space. Whatever was aboard the lead Cerna mattered enough to justify protection. The realization compressed the timeline. If the lead vessel reached shore intact, the opportunity would evaporate into a ground problem far harder to solve. The operator adjusted the TB2's flight path, breaking from the patrol pattern and banking into a wide arc that positioned the drone directly behind the convoy. This alignment was deliberate. Firing along the target's axis minimized guidance correction and maximized the probability that the missile seeker would stay locked. It was a technical choice with strategic consequences, because there would be no second chance to reveal intent without results. At 4:46, just as the operator prepared to release, the system interrupted him. A warning flashed across the display, indicating a laser malfunction and requesting recalibration. The timing could not have been worse. The Cerna was now about 7 kilometers from shore and beginning to slow, preparing for its approach. Each lost second narrowed the window. The operator's heart rate spiked, not from fear, but from the awareness that even flawless planning can be undone by a single component refusing to cooperate at the wrong moment. He cycled the designator off and back on, a procedure familiar to anyone who has ever trusted complex hardware in unforgiving conditions. The system ran its self-test, while the operator counted seconds that felt longer than they were. Below, the landing craft continued, oblivious to the pause above it. Finally, the indicator returned to operational. The operator redesignated the target, centering the crosshairs on the Cerna's bridge structure, and confirmed the laser rangefinder's reading as the distance closed again toward the ideal mark. During those moments, another detail emerged that unsettled him. The deck appeared more crowded than expected for a standard 30-man infantry complement. Additional crates were strapped along the sides, shapes that did not match normal equipment loads for a simple beach insertion. There was no time to analyze further, only to note the inconsistency and proceed. In 43 seconds, the contents of those crates would explain themselves, one way or another. The operator committed to the strike, knowing hesitation would only hand initiative back to the convoy. At 4:47, the MAML dropped cleanly from the TB2's hardpoint. Its fins deployed immediately, as gravity and guidance took over, the seeker searching for the laser energy reflecting from the target. Inside the missile, onboard systems calculated trajectory based on altitude, range, and closing speed. From 18,000 feet, with the target just under 8 kilometers downrange, the projected impact time aligned with expectations. The operator held the laser steady, understanding that even minor wobble could send the weapon off course. As the missile fell, the Cerna maintained its approach at reduced speed, still unaware of the threat descending toward it at hundreds of meters per second. On deck, Russian troops moved casually, some checking gear, others talking or smoking, behavior that suggested no alarm had yet been raised. The drone's stabilized gimbal kept the beam locked with mechanical precision, transforming the operator's small control inputs into unwavering guidance. This was the quietest phase of the engagement, where nothing dramatic happened and everything irreversible was already in motion. With less than half a minute to impact, a sudden change rippled across the deck. One sailor pointed upward, shouting "Ahat," his gesture visible even through thermal imaging. Awareness arrived too late to matter. Physics does not negotiate with warnings issued at terminal velocity. Trained for months and equipped for a specific task, were gone in seconds, their equipment intended to disappear ashore and reappear only as damage reports, instead surfaced as floating proof of intent. The psychological impact of that reversal cannot be overstated. Sabotage relies on deniability and surprise. Once both are stripped away, the entire concept becomes radioactive, forcing planners to abandon approaches that no longer promise silence. For Ukrainian intelligence, the strike delivered clarity that surveillance alone could not. It confirmed that Russian planning in the western Black Sea extended beyond observation or limited raids, reaching into coordinated infrastructure sabotage designed to shape the battle space indirectly. Knowing that changes everything. Defensive priorities shift, monitoring intensifies around vulnerable sites, and future drone patrols receive sharper guidance because the pattern has been exposed. Intelligence is cumulative, and this single engagement added a critical layer to an already complex picture. The TB2 eventually left the area, its mission complete, returning along another carefully chosen route that avoided the same air defense zones it had skirted on the way in. The sky that had hidden it hours earlier now began to lighten with the approach of morning, but the advantage remained with the side that had acted first. The drone's recovery mattered less than what it carried back in data, because wars increasingly hinge on who understands the environment faster, not who moves through it louder. In the days that followed, analysts compared this incident with earlier patterns and found a conspicuous absence. Russian special operations activity in the western Black Sea declined sharply, not because capability vanished, but because confidence did. When a mission fails in a way that exposes intent and method, repetition becomes dangerous. Silence in this case was the loudest indicator that something fundamental had changed. The water routes remained, the equipment still existed, but the calculus had shifted decisively. This single interdiction demonstrated how modern warfare compresses time. What once would have required layered patrols, manned aircraft, and large task groups was achieved through persistence, sensors, and a single munition released at the right moment. The strike was not remarkable because it destroyed a boat, but because it collapsed an entire operation before it could begin. In that sense, the explosion was less an ending than a punctuation mark, closing a sentence Russia never intended Ukraine to read. What made this moment decisive was not the blast itself, but the compression of discovery, decision, and denial into less than 2 minutes. The Russian plan depended on arriving unseen, landing quietly, and letting effects appear later without attribution. Instead, the entire sequence was observed end-to-end, from launch corridor to final detonation, by a single airborne system designed to do nothing quickly except watch. When that watchfulness turns into action, the result is not just destruction, but exposure. And exposure is uniquely corrosive to covert operations. The operator's role in that outcome was both technical and human. Holding a laser steady for tens of seconds, while everything below shifts and reacts, is not cinematic in the traditional sense, but it is where modern combat lives. There is no roar of engines or visual drama, only a narrow cone of light that must not drift. The discipline required to maintain that focus, knowing the consequences of even slight error, is a reminder that automation does not remove responsibility. It concentrates it. The TB2 itself embodied that concentration. Its value lay not in speed or payload, but in endurance and integration. Each of these changes compounds the original strike's impact, extending it far beyond the moment of explosion. This is how interdiction works in the information age. The immediate loss is small compared to the behavioral change it induces across an entire theater. The engagement also highlighted the growing importance of pattern recognition over sheer firepower. The TB2 did not stumble upon the convoy by chance. It was placed where traffic mattered, informed by prior reporting and an understanding of likely approaches. When the convoy matched those expectations, confirmation came quickly. This feedback loop between intelligence and surveillance reduces uncertainty and shortens response times, making surprise increasingly difficult to achieve, even for well-prepared forces. From an operational perspective, the trailing vessel's behavior may have been the clearest signal of all. Their rapid withdrawal, without attempt at recovery, demonstrated that the mission's secrecy mattered more than its personnel. That calculus is not unique, but it is revealing. It underscores how certain operations are valued primarily for their deniability. Once that shield is gone, the assets involved become liabilities, and disengagement becomes the rational choice regardless of cost. The Black Sea itself remains unchanged, but the way it is used does not. Narrow approaches, predictable transit lanes, and habitual timing patterns all become vulnerabilities when persistent aerial surveillance is available. Even without constant strikes, the knowledge that eyes may be overhead alters behavior. Ships spread out, routes lengthen, and schedules shift, each adjustment imposing friction that slows operations and consumes attention. In this sense, surveillance is a weapon even when it never fires. For Ukraine, the strike validated a broader approach that emphasizes selective engagement over constant pressure. Not every contact needs to be hit. Some only need to be understood. But when action is taken, it is chosen for its downstream effects, not just its immediate result. Interdicting a single landing craft was less important than revealing an entire method of operation and forcing its abandonment. That is efficiency measured in consequences rather than tonnage destroyed. The data captured during the engagement continues to matter. Video, thermal signatures, and communications traffic become training material, intelligence references, and planning inputs for future missions. Each recorded second increases the cost of repeating the same mistake. In this way, the TB2's most enduring payload was not the missile it carried, but the information it returned, packaged in a form that can be studied, shared, and applied again. As the situation settled, the sea returned to darkness and then to daylight, indifferent to the events that had unfolded above it. But for those planning movements across its surface, the night of June 24th did not fade so easily. It became a case study, a warning embedded in operational memory. The lesson was simple and unforgiving. If you can be seen long enough, you can be stopped, no matter how quietly you intend to arrive. This is how modern conflict reshapes itself, not through constant escalation, but through moments that redraw boundaries of confidence. A single drone, a single decision, and a single missile ended an operation designed to stay invisible. The result was not just a destroyed vessel, but a shunt that followed, as plans were shelved and routes reconsidered. In that silence, the real impact of the strike became clear. At 5:30 local time, the Sea of Azov looked empty to the naked eye. But one Russian Bayraktar M-class corvette was already in the last calm minutes of a launch cycle, its deck teams moving with the practiced routine of a ship carrying 8-caliber cruise missiles and a plan to aim them at Ukrainian cities before sunrise fully arrived. The watchstanders expected the usual threats: distant aircraft, coastal batteries, maybe a stray unmanned boat. Nothing that could close the distance fast enough to matter. What they could not see was that 7 Ukrainian drones were already inside the problem, split into roles the way an air wing splits into scouts, jammers, and strikers, each group timed to turn Russian procedures into a trap. The attack did not begin with explosions or radio chatter, but with a single high-speed lead drone, a Rebecca, cutting low over dark water and coastal clutter so fast that the first warning was not a radar return, but the sudden instinctive fear that comes when a motor's whine is close enough to feel. The Russian checkpoint guns opened fire first, filling the dawn with tracer lines and the blunt snap of 23mm shells that could shred a small airframe into fragments in a heartbeat. The gunner could not clearly see the target against the shifting background of sea, shoreline, and early light, but he could hear it, and that was enough to start walking rounds toward the sound, betting that volume and pattern would do what optics could not. The Rebecca answered by accelerating harder, turning speed into armor. The lead drone surged through 400 kilometers per hour and then pushed beyond it, riding the thin margin between control and chaos until it reached roughly 432 kilometers per hour, too fast for a human gunner to smoothly track. Shell bursts popped around it like sudden white fists, close enough to jolt the operator's nerves through the screen, yet not close enough to end the run. The drone snapped past the firing lane before the barrel could follow, but the real damage was already done. because gunfire is a flare to everyone listening. Within a radius of 10 kilometers, Russian positions that had been quiet now knew something was happening, and the warning did not move through formal command nets first. It moved through telegram, through hurried messages and forwarded clips, spreading faster than disciplined radio traffic and stripping away the one advantage small drones depend on: surprise. What had started as a clean hunt turned instantly into a crowded sky of reactions, guesses, and weapons being swung toward any noise. The Rebecca's operator saw the cost of that lost surprise in the worst possible way, when the video feed shimmered and the screen filled with a threat that had not been real until the final second: power lines. They were nearly invisible against the darkness until the drone was already committed, and the lines carried 110,000 volts, the kind of contact that ends electronics and airframes at the same time. The operator yanked the drone upward, clearing by only a couple of meters. That violent pull-up did not come free. Instruments flickered, the compass spun, and for several agonizing seconds, the drone was effectively flying blind, held in the air by momentum, muscle memory, and a fragile link that stuttered under the strain. Then a radio tower emerged out of the gloom, its guy wires stretching into space like invisible tripwires. The operator banked hard left, missing the cables by inches, and in that same window, 2 more Rebecca's slipped through about half a minute apart using the chaos as cover. Those trailing Rebecca's were not there to die heroically against the ship itself. They were spear drones, built to carve out blindness by attacking the radars that give every launcher and gun its confidence. Their goal was simple: if the shore-based sensors could be broken, the corvette would be forced to fight alone with a shorter view of the world, and time would become the Ukrainians' ally. While the Russian defenders chased the fastest noise, the spear drones hunted the eyes and ears behind it. Farther north, a second group took a different path. Slower but heavier. 4 Bober drones moving at around 200 kilometers per hour, carrying the warheads meant to do irreversible damage once the defenses were confused. They were the hammer, but even a hammer needs a clear swing, and Russian forces were already building the counter. A Repellent 1 jammer waited along the route, flooding control frequencies with roughly 400 watts of electromagnetic noise. A blunt wall meant to sever the link and drop drones harmlessly into fields and water. One Bober's screen went black as the jamming hit, the kind of sudden silence that usually ends a mission, but the Ukrainians had planned for that exact moment. Pre-programmed waypoints took over, switching the drone into autonomous navigation, using accelerometers and optical landmarks to keep moving through the interference like a pilot flying on instruments through fog. Minutes later, the video returned, and the Bober was still on course, which meant the Russians had failed to stop it, and also revealed they were using predictable electronic doctrine. Then the route tightened into a ground-level knife fight. A BTR-82 blocked a highway segment, its machine gun already firing in preset patterns designed to catch a drone that tried to thread the obvious corridor. The operator dove into an industrial zone, using buildings to break line of sight, but those same buildings sheltered Russian soldiers who poured out at the sound of motors. The drone held low altitude, around 10 meters, exploiting radar shadows created by Earth curvature, turning physics into concealment while bullets chased sound and glimpses. Statistics eventually punished the plan. Concentrated small arms fire from coordinated shooters finally connected, and one Rebecca spiraled down into a parking lot and detonated on impact, a loss that instantly narrowed the margin for every choice that followed. Now there were 2 Bober drones and 2 Rebecca drones left, and the mission's structure became brutally simple. Either the remaining spear drones would blind the network quickly enough for the Bobers to reach the corvette, or the next layer of Russian defense would erase what was left before the strike could even begin. The next layer revealed itself without warning. as the lead replica crested a low ridge and the operator's screen filled with something the briefing said should not be there. In the space of a few heartbeats, the mission changed shape. A Panzer air defense system swung into view, already tracking, already reacting. There was no time to reroute or reconsider. In roughly 4 seconds, the operator would either exploit everything he knew about Russian air defense doctrine or watch the remaining drones vanish in overlapping bursts of shrapnel. The Panzer did not hesitate. 6 interceptor missiles launched almost simultaneously, but these were not the large surface-to-air weapons meant for aircraft. They were specialized anti-drone interceptors, each weighing about 12 kilograms and carrying a fragmentation warhead packed with 200 tungsten spheres. When triggered, those spheres would expand outward at roughly 1,800 meters per second, forming a donut-shaped kill zone about 10 meters across, perfectly sized to erase small, unmanned aircraft. The Panzer operator used layered engagement tactics, sending missiles to staggered altitudes. The first was set to burst at around 50 meters, the second at 30, the third at 10, forcing any target to fly through at least one lethal ring. The fire control system calculated intercept boxes in 3 dimensions, building a cage of predicted positions where the drone should die. Proximity fuses pulsed with radio energy, waiting to sense enough metal to justify detonation. On paper, the Rebecca was already finished. But the Ukrainian operator had studied these systems obsessively, and he knew about the weakness hidden inside the sophistication. Each missile carried a safety feature, a roughly 1.2-second arming delay after launch, designed to prevent detonation too close to the launcher itself. At the Rebecca's speed, that delay translated into more than 100 meters of protected space. The instant he saw the launch flares, the operator shoved the controls forward and dove straight at the Panzer. The maneuver looked suicidal, but physics was on his side. The missiles streaked overhead while their fuses were still inactive, unable to detonate even as the drone passed within meters of the warheads. By the time the safety delay expired, the Rebecca was already below them, using the launcher's own precautions as a shield. The operator leveled out at roughly 5 meters altitude, skimming terrain and lining up on a far more valuable target sitting just behind the air defense system. That target was a Podlet K1 radar, a critical node that fed targeting data to Russian launchers across a massive area. Destroying it would not just blind the Panzer in front of him, but fracture the entire local detection network. The Panzer's twin 30mm cannons opened fire in response, each barrel cycling at thousands of rounds per minute, throwing dense curtains of metal into the air where the drone was predicted to be, not where it actually was. The problem for the gunner was time. Both the water and the drones moved, rose and fell. Confusing systems designed to separate motion from clutter using predictable patterns. At variable speeds between 80 and 120 knots, the Doppler filters failed to draw clean lines between threat and noise. Every few seconds, the computer's clutter rejection logic decided it was safer to erase what looked like false targets rather than risk tracking phantom waves. Each time it did, a real drone disappeared from the screen, only to reappear a moment later in a different position. The operators were fighting their own software as much as the incoming attack, watching symbols blink in and out while the timeline collapsed. The ship had trained for missile raids, not for this kind of low, erratic swarm. The AK-630 M2 duet system spun up next, its twin 30mm cannons reaching a combined rate of fire near 10,000 rounds per minute. The weapon was designed to shred large, fast, predictable anti-ship missiles, like the P-270 musket, heavy weapons following smooth trajectories. Against small drones darting and juking every couple of seconds, it was like trying to swat insects with a sledgehammer. The fire control computer leaned on Kalman filtering, predicting future positions by averaging past motion with physical limits. The math never converged. The drones changed direction faster than the system could recalculate, ensuring every firing solution was obsolete before the first shell arrived. Tracers stitched patterns across empty air, while the drones slipped through gaps measured in meters. Still, the crew escalated. The PK-10 decoy system launched clouds of chaff, aluminum strips cut to resonate with the targeting radars and bloom into massive false targets across every display within dozens of kilometers. For radar-guided missiles, it would have been a nightmare of confusion. For human operators watching through cameras, it was just a glittering distraction. Bright sparkles drifting in the early light while the real targets remained sharply visible. The drone operators ignored the spectacle and stayed locked on the ship. Next came the TK-25E electronic countermeasure suite, blasting roughly 200 watts of energy across frequencies from 20 MHz up to 40 GHz, a broad attempt to tear apart control links. Against conventional radio-controlled drones, the tactic would have worked instantly. These drones used frequency-hopping spread spectrum, jumping across more than 100 channels every second in patterns known only to their operators. The jamming caused brief pixelation and dropped frames, degrading the video feed from high definition down to something rough, but usable. Annoying, not decisive. The corvette's captain sensed what was coming and ordered evasive maneuvers, sharp S-turns at maximum speed. The order ran into physics. A vessel weighing roughly 949 tons does not change heading quickly, especially at speed. It took around 15 seconds to swing 30 degrees. A drone needed a fraction of a second. The Rebecca operator recognized the rhythm immediately and timed his approach for the steady interval between turns, riding the ship's inertia like a metronome. At 500 meters, he switched to full manual control as the radar mast filled his screen. The duet cannons could not depress far enough to engage a target that low and close, and sailors on deck brought up PKM machine guns instead. They faced an impossible human limit. The drone crossed their field of view in under a second. Eyes need time to focus, then more time to track, then still more to aim. By the time a sight picture formed, the target was already gone, leaving only after images burned into vision. Bullets chased where the drone had been. The first bobber rose into view at the last moment, aimed directly at the ship's mast, where radar arrays, communications links, and data networks converged in a tight cluster of critical hardware. Its shaped charge detonated on impact, and in an instant, every radar and external communication system went dark. The bridge lost its eyes and ears at the worst possible time, just as the captain screamed for emergency missile launch procedures. Those procedures needed time the ship no longer had. Gyroscopes had to align, targets validated, missiles warmed. The sequence took roughly 2 minutes under ideal conditions. The remaining bobber drones were less than 30 seconds away. The corvette was now functionally blind, unable to see threats, unable to coordinate defenses, and unable to execute the strike it had been preparing since before dawn. The attack was no longer about confusion. It was about inevitability. The second bobber dove toward the port side at a shallow angle, its operator aiming for a precise section of hull between frames 44 and 52, where the missile magazine sat behind about 15 millimeters of steel plating. At 100 meters, the operator made final adjustments, accounting for the ship's drift and slight list from the last hard turn. The shaped charge needed a near-perfect 90-degree impact to achieve maximum penetration. Too shallow and it would glance. Too steep and it would waste energy. The operator had rehearsed this moment hundreds of times in simulation. But simulation does not include shaking hands, salt spray on the lens, or the knowledge that missing meant more missiles would fly toward cities. The bobber struck exactly where intended, and the shaped charge produced another Monroe effect jet, punching through steel as if it were paper and spraying molten copper into the missile magazine's interior. Systems failed together rather than separately, compounding the damage in seconds. The jet from the second bomber did not stop at the first layer of damage. It tore through missile handling equipment tied to the vertical launch cells, rupturing hydraulic lines, electrical buses, and coolant systems that turned stored missiles into functional weapons. Hydraulic fluid sprayed under extreme pressure across exposed panels, creating immediate arc fires as electricity met atomized oil. Coolant lines burst next, releasing toxic hydrazine derivatives into confined spaces already filling with smoke. Most critically, the blast severed safety interlocks, designed to keep warheads inert until commanded. 8-caliber missiles remained physically intact, but electrically isolated, armed in theory, yet impossible to launch. The ship that had been minutes from firing now carried its own weapons as liabilities rather than assets. Internal alarms cascaded through compartments as damage control teams ran into spaces that were already too hot, too dark, or too contaminated to enter safely. Despite the violence of the strikes, the corvette did not immediately sink. Its hull integrity held, but only barely. Fires burned unchecked in several sections of the superstructure, fed by ruptured systems and residual fuel. Smoke poured from openings along the deck, visible for kilometers as the remaining crew fought to keep the ship afloat rather than combat capable. The drones that had delivered the blows were already gone, their operators hundreds of kilometers away, watching the aftermath through degraded feeds. 12 hours later, the corvette crawled back into port under escort, moving slowly, scarred and blackened, with emergency pumps still running, and damage control teams rotating through exhaustion. The superstructure was visibly warped. Sections of the hull showed breaches that had been temporarily sealed. Investigators would later estimate that full recovery, assuming replacement parts could even be sourced under sanctions, would take at least 18 months. Until then, the ship was effectively removed from the war. The 8-caliber missiles meant for Ukrainian cities remained unfired, trapped inside a hull that could no longer support their launch. The broader impact rippled outward quietly rather than explosively. A single corvette's absence forced adjustments to patrol schedules, coverage gaps, and launch planning across the region. Systems designed to work in layered harmony had been peeled apart in sequence, each weakness exploited at the moment it mattered most. What made the strike resonate inside military circles was not just the damage, but the method. 7 drones, built around speed, autonomy, and commercial components, had dismantled defenses worth hundreds of millions of dollars by leaning on physics, human limits, and doctrinal rigidity. The Russians had weapons for every threat they expected. They struggled against the one they did not. From bunkers roughly 300 kilometers away, Ukrainian operators had neutralized a warship valued at roughly $500 million using airframes and electronics that could be sourced on the open market. The imbalance was not symbolic, it was measurable, and it forced planners on both sides to rethink assumptions about cost, control, and vulnerability in modern naval warfare. The Sea of Azov returned to its quiet surface by mid-morning, giving no hint of the layered fight that had unfolded just hours earlier. No wreckage marked the battle, no sinking ship drew attention. Yet the absence of a missile launch that day carried its own weight, measured not in explosions, but in what did not happen next. The strike demonstrated how quickly a mission can invert when every defensive response triggers the next vulnerability. Guns revealed positions, jammers forced autonomy, interceptors exposed arming delays, radars became priority targets. Each reaction tightened the trap rather than opening an escape. The outcome was decided less by any single weapon than by the order in which systems failed. For the sailors aboard the corvette, the morning ended with survival rather than victory. A narrow margin bought by hull strength and relentless damage control. For the planners who had counted on 8 missiles lifting off before dawn, the result was a blank space where certainty had been. The ship survived, but the mission did not. This was not a story of a sinking, but of a capability removed at exactly the wrong moment. A launch sequence interrupted by seconds. A network blinded in minutes. A platform sidelined for months. In modern warfare, that can matter as much as destruction itself. The drones never needed to outgun the ship. They only needed to arrive in the right order, at the right height, at the right time. When they did, the outcome followed naturally, governed less by intention than by physics, timing, and the limits of human reaction.